Hi everyone, I'm back again. It's been a while now. I'm here to solve LeetCode problem number 76, minimum window substring. Let's read the problem. Given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. So what's going on right here? So we're given a string s and a string t such that we want to find the minimum window substring such that all the characters in t are contained within the substring. So let's take a look at this string right here. You have it's a pretty long one, but the output is BANC is because this substring right here, BANC, contains all the characters that are within T, A, B, C, right? You have A right here, you have B, and then you have C. This is the minimum one. The minimum window substring BANC includes A, B, and C from string T. That's exactly, that makes perfect sense because you also have this substring right here. It's ADOBEC, which also contains A, B, and C, but this is a longer substring than this 4-character substring that we have towards the end. Obviously, if the string S is A and T equals A, then all we're left with is A. And if the string T is greater than the string S, as we see right here, then you can't get, if both A's have to be included. It says both A's from T must be included in the window, and since S is less than T, you can't do it. Okay, this is a sliding window problem. I had a lot of problems with this problem, but I'm going to try my best and see what I can do. Let's see what we can do. And this solution I'm about to demonstrate is from LeetCode. I'm doing it to give myself practice, but this is a canned solution that I found on the internet, and all the credit goes to him and not me. Let's start with some constraints. So we have m equals s dot length. We have n equals t dot length, and then we know that 1 is less than or equal to m, which is 1 is less than or equal to mn, which is less than or equal to 10 to the 5th. So we know that both strings s and t can get very large as 10 to the 5th. Here's another constraint. S and t consist of uppercase and lowercase English letters, which makes perfect sense. Let's take a look at the topic. This is obviously a sliding window problem, but let's check anyway. I always like to record this just in case. This is a hash table string or sliding window problem. Okay, so let's design the approach. Okay, so let's get started. So basically, the way to think about this problem is that you're gonna have a dictionary that holds the frequency of each character encountered in T, as well as a sliding window that goes through the input string S. And whenever we find that the sliding window is gonna keep going, and only record when we've hit one of these characters that belong in T. And when we know that, the sliding window, it equals the sliding window, it equals what we have in T, then we know that we can make a calculation to determine whether the sliding window has hit the answer or not. And once we do that calculation, then that gives us the ability to update the left side of the sliding window and increment it, while the right side of the sliding window will just keep going, adding new characters until we hit the condition every time that the sliding window has hit a substring that contains all the characters that are found in T, and that's when we make a calculation to see if we found the minimum one, right? So this problem can get a little unwieldy, but let's get started. If T is an empty string, then return the empty string. What we're going to do is define two dictionaries, count T and window. Populate the count T dictionary. Then what we're going to do is define two dictionaries, count T and window. Define variables have and need. Define variables result and result length. Define in a left pointer. So let's get started setting up the skeleton of the problem. If T equals the empty string, then return the empty string. We're going to have count T, and we're going to have window equals two dictionaries, and then we're going to populate count T. So we're going to do that by doing the following. For C in T, we're going to do count T C equals 1 plus count T C comma 0. And then we're going to do two variables, have, need equals 0 and length of count T. The reason why you have is 0, we haven't found any within the sliding window. We haven't found any of the characters that we need yet, but we know that we need to find a substring with count T number of the characters involved, right? Now we have res, and res len equals -1, -1, and then we're gonna do res len. I'm also gonna set as -1, and then we have to define a left pointer, L equals 0. So then I'm gonna set up the skeleton. So we have L, R equals res, and then return S L R plus 1 if res len equals -1 else. Okay, so this is the skeleton of the program that we have. So let's get started for with the rest of the program. Define a for loop that goes up to len s update, add new values to the window, right? Add new values to the window. And then this is the thing I always forget. Do a while loop. Do a while, give me 1 second. Do a while loop when okay. I missed a step right here. Hang on, give me 1 second. I missed a step. Right before the while loop, we have to check to see if the variable that we just added to window is if the character added to window is one that we want. Check to see if the character that we just added to the window is one that we want. If so, update having, right? We have to update having. Do a while loop when not having but have. When have equals need, right? This is when so basically we're letting the sliding window do its thing, and then just we're checking to see if it's one of the characters that we want, which is a character that is within the string t, and if so, we're going to update have, and then we'll do it while loop when have equals need, right? We found our two dictionaries have the same number of characters that match each other, where each character is a character of the string t. So then what we're going to do is update res and res len. Then what we're going to do is update the left side of the sliding window and subtract the character that the left pointer points to. And then what we're going to do is do another check to see if we need to update have. And then lastly, increment the left pointer. As you can see, this is a lot. This is a lot of code, and so let's just go for it. Okay. For r in range len s, define add new variables to the window. Right. C equals s of r. Window c equals 1 plus window dot get c0. And so we have to do this check, right? If c in count t and window c equals count T C. This is when we know that the character that we found is in the count, and the window, the window has the same number of characters has the same count in count C. The count of the character is the same as the count in the window, so that means that we found, for at least one of the characters, we found what we need, right? So have plus equal 1. Then while have equals need, right? Have equals need. Then we're gonna update res length, right? So if r minus l plus 1 is less than res len. Give me 1 second. You know what? I'm actually gonna change this to this is how LeetCode did it. Float infinity. Let me just do the same thing. Is less than res len. Then what we're gonna do is do res equals lr res len equals r minus l plus 1, right? Then what we're gonna do is c equals s of l, and we're gonna do window c minus equal 1, and then if c in count T and window C is less than count T C, then what we're going to do is do have minus equal 1. Then we're going to do L plus equal 1. Let's see if this works. Whoops, this is wrong. I changed res len does not equal I see. I made an error right here. Forgot dot get. Made an error somehow. This is wrong. Res len should be float. This is completely wrong. Okay. This is len, need is len count T. There we go. Okay, this is a rather challenging problem, and so I'm just gonna copy the time and space complexity right here. The time complexity is O of n, and the space complexity is O of s plus t, where s is the length of the input string s and t is the length of the input string t. This is a hard problem, a very, very challenging sliding window problem. The first one I've done that's hard, but I just have to keep practicing, and so that's really why I'm doing these videos, okay? So thank you everyone, and I'll see you at the next one.